So today I am taking a look at a next-gen firewall package for OPNsense. Now OPNsense is of course my absolute favorite open source firewall router. Zenarmor is not open source, but I'm still taking a look at it anyway, because if you use OPNsense, it's a package you might want to consider. It's especially useful if you're in a larger environment where you have some requirement to do blocking. So you might be familiar with something like DNS-based blocking using AdGuard Home or Pi-hole. Both of those certainly work and they have their use case, but if you actually need to inspect traffic on the wire flowing over your network, Zenarmor is a tool that will do that. Now, Sunny Valley Cybersecurity, the makers of Zenarmor, they did send me a license to make this video, but no money changed hands. They'll see this review the same time you do. Let's get started on this adventure. So if we're going to call something a next-gen firewall, we probably need to get behind the marketing fluff and understand what that really is. So most firewalls today have essentially two different options on how they can deal with filtering. So at the most basic level, we have simple access control lists. These are really commonly used in networks today to protect layer 2 segments, things like preventing DHCP or router advertisement hijacking. These are really basic. They basically look at the contents of a packet and decide if it should pass or not. And that's all they do. They can't associate multiple packets with each other. You can look at fields like the MAC addresses, the IP addresses, UDP, TCP ports, protocol numbers, things like that. That's all you have access to is the information in one packet or MAC frame. Going up a layer from there, we have the modern stateful packet firewall. This uses connection tracking to match up packets that belong to an existing session. So I'm Applard. I write some firewall rule that says Applard may access the internet. Then I write another firewall rule that says the internet may not access anything. So what happens when I send a packet out to YouTube? I expect YouTube to respond to me with some data, but if I just had a simple stateless firewall, the firewall wouldn't know that my request expected a response. It wouldn't match those two up together. So that's what a stateful firewall does. It keeps track of existing sessions, and it uses rules from the first packet in the session and matches up subsequent packets. So if my rule says Applard is allowed to connect to the internet, I initiate a connection to YouTube, YouTube responds, that packet coming in from YouTube isn't a foreign packet from the internet. It's matched up with an existing session, and that session was allowed because it was initiated by me. So that's the modern connection tracking stateful firewall. That's what OPNsense does as its bread and butter. Layer 3, layer 4, stateful packet filtering. This is also what a lot of people confuse with NAT as being security, but really the connection tracking can be done on v4 and v6 just as well. NAT doesn't need to be involved in that. So what do we do for the next level of security, the next-gen firewall marketing term? Essentially what a next-gen firewall is a class of deep packet inspection firewalls that take a look beyond the layer 3 and layer 4 headers and connection tracks. They look at the contents of these packets and they try to understand the application level traffic that's going on. So Zenarmor in particular, and most NGFWs, are designed to protect client access. So users that are accessing the web, they're accessing other applications on the internet. This is connections that are going out. Ordinarily, your firewall would probably have a rule that says normal computers are allowed to access the internet. And maybe you have some IP block lists that block certain countries or things like that at the IP level. Maybe you block certain ports if you have a specific need to do that. So what a firewall like Zenarmor is going to do is it's going to try to classify packets based on their protocol. If there's specific peer-to-peer protocols that have notable signatures, it can detect that. If they're HTTP or TLS traffic, it's very easy to see what the website going to is. That'll be in the SNI header of a TLS connection. If it's unencrypted HTTP, that's just all out in the open to be inspected. And so doing this method means that all of the traffic is going to get filtered and you have a lot more granularity on especially web traffic, but also web adjacent traffic too, to be able to detect and filter it. Now of course you could use DNS-based blocking, but that only works if your client's cooperative. So if you're running a school network, for example, your clients are almost never cooperative. They're going to find any excuse they can to get around the firewall. And so you're going to need something a little bit more aggressive than just DNS. Now what this is not going to help you protect is your servers. So this is primarily looking at threats such as websites you don't want your users to visit, websites that could be dangerous to your users, things like that, known malware, command and control servers. Most of that stuff shouldn't be happening on a server network anyway. If you have a problem with your servers connecting to ChatGPT on their own, you probably should be pretty scared of those servers. So another neat thing about Zenarmor is that it is just the next-gen firewall. It is not the base operating system. So you can install Zenarmor on Linux or BSD, but it includes a package for OPNsense that's much more tightly integrated with OPNsense than their Linux or BSD offerings. So if you run Zenarmor on Linux or on BSD, you can build out the whole next-gen firewall, but there's no user interface local. You have to use their cloud managed system. However, with OPNsense, they brought their whole management system onto the local OPNsense box. So if you use Zenarmor with OPNsense, it's fully local aside from licensing. Now the other thing that may or may not be local is your database. So Zenarmor needs a database backend. It supports MongoDB and Elasticsearch. And if you use MongoDB, you can run that on the OPNsense firewall as well. The packages will help you with that. My experience, MongoDB is rather slow, and if you're in a big environment, you're probably going to want to be using Elasticsearch. However, I did try to set up Elasticsearch on a Proxmox system, and Elasticsearch decided that I was not worthy of the amount of RAM it needed. It's extremely RAM hungry, and it would just quit. So anyway, with all that said, let's get started on installing Zenarmor on OPNsense so we can see what that process is like and get it set up. So I got my little Protectly firewall. We're going to install Zenarmor on this. Let's see how the process goes. So Zenarmor has a page on how to install it, but it's really quite simple. We basically just have to add the plugin, add the package. Package for OPNsense, nice and easy. So over here on my OPNsense system, I'm going to go to System, Firmware, Status, and click Check for Updates. We have to be on the most recent minor version for whatever major version you're on. So if I'm on major version 23.7, I have to be on the most recent minor version. Yep, there we go, no updates available. So currently at the time that's writing, it's 23.7.11. So if you're not already up to date, do an update to OPNsense first, then we'll continue with the install. So now we go over here to plugins and we search for Sunny. So Sunny Valley is the name of the company that runs Zenarmor. So here we go, so OS Sunny Valley, we click plus and we wait for that to install. That's going to install the repository onto OPNsense. And from there, we can install packages from the Sunny Valley repository. So they're not distributed by OPNsense, just this kind of pointer to their repository is. So once we install this pointer, then we can go into packages and install the package. So now that that's done, we go back to the plugins tab and we see a couple more things happen. So Sensei, Sensei Agent, Sensei Updater. So Zenarmor used to be named Sensei, so the package is called Sensei. So we click plus on that guy and say install. So now we just wait for this to finish, and then it should show up on our sidebar. Okay, so once we see the done, then we can refresh this page. So now on our sidebar, we have Zenarmor. So it's going to ask us to do some initial setup the first time. So we have to read the terms and conditions, etc. Now we have to choose our database. I would definitely not recommend SQLite. That's probably going to be real slow. I used local MongoDB. So at this point, we're going to install MongoDB, or you could set up and configure a remote Elasticsearch server. If you're running a network with like a decent number of actual users, that's probably the approach you're going to want to take. There's quite a bit of data coming in. Elasticsearch does a better job at indexing and things like that, even though Elasticsearch needs an outrageous amount of memory. So now we're going to install MongoDB, and we'll come right back. Okay, so we're done with MongoDB, so we click Next. So we have a couple different options here. If you're running Zenarmor, you probably care about more than just reporting. You probably want to do blocking too. So in general, we want L3 mode. So we're going to pick that. And so I have options on what interfaces I can pick. So I'm going to just pick both of them. So that'll be my LAN. And I don't know, we'll call this guy. There. So we got two different security zones and two interfaces. And there we go. So you have the option of choosing your license here, or you can start with the free edition. There we go. No email required. And here we are. So now that that's done, let's go ahead and set it up. So while I did just set it up in an example, I'm actually going to use my own router on my own network for these demos. So I've had Zenarmor running for over a month now on my home network, and I've gotten a feel for how it works, how to set things up, etc. So I'm going to go through that process again on my network now. We're going to see how that looks. So we're here in the dashboard. So when you install on OPNsense, you get a new tab here. So we've got all the usual stuff, firewall, routing, services, Zenarmor. So I'm just at the dashboard here. You can see stuff's going on. I'm running MongoDB. Not a lot going on right now. So one of the cool things we can do is we can bin things into devices. So this guy here says they found 86 devices on my network. It'll try to do reverse DNS and see if it can figure out what they are. So some of them got a host name that way or by inspecting DHCP packets. So it discovered these devices on my network. It shows their legacy IP address, but under the hood it does actually match all their v6 addresses correctly. So I believe it's actually filtering by MAC address and not by IP. So we can see these are all of them. I got no cameras, I got some desktops. Gaming, that's not a gaming console. It did its best, it tried to filter these guys. Those are all laptops. Some of these are mobiles. That is a TV. Most of these are these 4 are access points. That one's a camera, so we'll go move him over to cameras. And I think he is keyhole 1. So I could go through these and categorize them all. So Big Store is a server. Corona is a server. Columbia is a printer. Basically, if I go through this process and I categorize all my devices, then I can add filter rules based on category instead of having to call out individual devices. So depending on how you manage your network, this could be very useful. It could be not super useful, but I thought it was a pretty cool feature that I liked. So despite me liking the devices page, there are a couple of quirks you should be aware of, especially if, like me, you're running a very complicated IPv6 mostly network using DHCP option 108. It does not seem to be particularly happy with that exact setup. If you're running a normal dual stack network, you're probably fine. So over here I've got a bit of a demonstration here. So I searched for Spaceship 3. That's the name of my laptop. So I name most of my devices after space-related themes. My desktop is White Knight 2. My first laptop was Spaceship 1, and then Spaceship 2, which is this beautiful plane here. And the next one on the sequence would be Spaceship 3, which doesn't exist yet in the real world. So anyway, search for Spaceship 3. I expect to get Spaceship 3, which used to have an IPv4 address of 172.278.1. So it found this device a while ago, and it called it Spaceship3.local, which makes sense because it probably saw some MDNS traffic from it. And it categorized it as others, so that's a laptop. And nothing is wrong with this, except this is not Spaceship 3 anymore. So in an IPv6 mostly network, we advertise DHCP v4 option 108. I have a video upcoming on this, so I didn't make a video on that topic yet. But basically, if a device is capable of acting without IPv4, it can choose to reject its IPv4 address over DHCP. And Apple devices all support this, and they have done that. So this device used to have that address. It no longer has that address. It now has no IPv4 address. So it'll have a couple of IPv6 addresses, one of which is a IPv6 CLAT translation. So it will create its own IPv4 address on the local host, give that a corresponding v6 address in the v6 space, and translate v4 packets using 464x lat, which is beautiful. So this number here, 192.0.2, that is the CLAT number. So if we come down here to Wikipedia, there's a range here that was reserved for DS Lite. And this range for DS Lite is also used by 464x lat for gateways. So now Zenarmor has found every device on my network that has a CLAT. All of them use 192.0.0.2, which is part of the DS Lite range, as their CLAT address. And somehow it can't figure out how to differentiate them. And I guess that makes sense if you think about IP addresses as addresses, but if it looked at the MAC address, it would realize that these are all different machines. So in this case, it says this Spaceship 3 is actually Luis's iPad. And I would bet this is actually Luis's iPad. And this one here just has an FE80. I guess we can just delete that one, because we need to keep FE80s around. This one is Suzanne's iPad, but it's also Spaceship 3. This one is actually Spaceship 3. That one is also Spaceship 3. And that one is Luis's iPad. That one is Spaceship 3. Yeah. So it's a bit confused on my 464x lat setup here. I'm guessing most of you are not doing 464x lat at home. But even if you're not, it still gets a little bit confused by Slack privacy addresses sometimes. These are the IPv6 addresses that change daily. So coming back here to the 236 new devices I have, if I view those, a lot of these say other device. It's like this one, I don't know what it is. It's .130. I could go look it up, but I can't be bothered. So, but it has an IPv4, and same with this one. I'm not bothered to look that one up either. But they exist, and they're probably real. This guy here, he's got a v6 address. And this guy here, he's got a v6 address too, and it hasn't been able to identify it. It still says initial identification in progress. And so if I click down on all these other devices, all of them just have a v6, and they don't have a v4. So what's happened is, it's trying to identify a device, and once it identifies it, it kind of locks that in. So for a given device, it'll try to find its MAC address, its v4, and its v6. Then when the v6 changes, it sees a new device, and it's like, well, this device already has a v6, so it can't be that one, right? And it's not putting all of the v6s together, which is a bit odd. If you were on an enterprise network running DHCP v6, you would never have seen this. So my guess is that their test setup doesn't use Slack with privacy addresses, which makes sense to me why they wouldn't have seen this. But it's also a bit of a frustrating issue for me as someone who does use Slack with privacy extensions, that it's not grouping these devices together properly when they change their v6 address. And then, of course, I have 5 pages of these, and all of them are v6 devices we detected some number of days ago. So I could merge these with parents if I could figure out what their parent was, but if this was a temporary address 6 days ago, it probably doesn't even exist anymore, and I should probably just delete it. So device page, very useful at the start. This little quirk makes it a lot less useful to me. That said, if your device is there and you write a rule based on a specific device, it'll actually use the MAC address and it'll catch all of the v6 addresses, even if it didn't group them together properly on the Devices tab. So that functionality still works. It's just that the Devices tab will have a bunch of extra devices for all these temporary privacy addresses that aren't real. I mean, the addresses were real, but they're not real anymore. They've expired. So next up, after we've categorized our devices, we can start creating policies. Now, policies are one of the things that changes with license levels. That's something to be aware of. So here on my setup here, I have the default policy. You're always going to have a default policy, and all devices that don't fit into any other category will always take the default policy. Now, in addition to the default policy, there's one other option you have, and that's to block untrusted devices. So back in the devices page, we could mark devices as trusted or untrusted. You have the option here to say untrusted devices have no access at all, and then beyond that, trusted devices fill into the default policy or additional policies beyond that. If you have a free license, the default policy is what you can do. The home license allows 2 additional policies, and beyond there you have more flexibility in creating policies with business or enterprise licenses. Also, all of this only applies to interfaces that are running Zenarmor. So in my case, I'm only running Zenarmor on my LAN interface, not my server interface. So my servers aren't affected by these policies because Zenarmor isn't protecting that interface. So I've chosen for my default policy to be pretty open in here. I've chosen to block pretty much just malware and dangerous things. I'm not filtering what my users can access other than things that are actually dangerous to them. So let's take a look now at what we're capable of filtering on within a policy. What options do we have? So for non-default policies, we'll have more of the configuration tab. We'll get to that in a bit. But then the other tabs we have are security, app controls, web controls, and exclusions. So each of these are essentially a type of traffic or a type of category that we can enable and disable filters on. So first tab is security. We have all of these categories in essential and advanced, and we can choose to allow or block essentially anything from these categories. So these are not terribly specific. They're probably getting these lists from other sources, but we have known DNS over HTTPS, malware sites, phishing sites, hacking related sites. I like those. Those are fun. And other stuff like that. And then down a bit further, we have some more unique stuff you might want to block or allow. That one might want to be blocked. That one's new. Some of these aren't necessarily insecure on their own, like DNS over HTTPS or DNS tunneling, but they allow your user to evade certain types of blocks, and so blocking them here might be a good idea, depending on your use case. Now, Zenarmor is still blocking based on TCP, TLS, web traffic, so even if your user does evade DNS, they still won't evade Zenarmor, but sometimes those things are just nice to block anyway. So next up we have app controls. This is where we have a lot of things we can look at. Lots and lots of categories to drill down into. If you want to block a common website, there's a good chance it'll be in here. So for example, AI tools. Every school now is trying to block ChatGPT. Boom, look, ChatGPT's blocked. Google Bard, they're blocked too. Oh wow, look at all these guys. But I could just come up here to category and I could block the whole thing. So subcategories, there's 26 AI tools in here to look at. Don't have to click all 26, we can just block them all. Same with ads, 352 subcategories going on here. So these are different ad networks. We can scroll through and they're all here, all over. Now I'm not going to comment on sites that will ban you or otherwise prevent you from using their site if you block ads. No idea how that works. I didn't rely on this for ad blocking. I use a in-browser ad blocking extension, so this wasn't something that was needed for my particular use case. But it's something that's certainly here if you want to look at it. Block, yeah, so even stuff like IMAP or POP3, these are protocols, these aren't websites, but we could block IMAP and POP3 if we wanted to. Some of these are webmail, some of these are not. So secure email, so SIMAP and SPOP3. These would be SMTP, or secure SMTP. So some of these, again, are based on, it's like BitTorrent is going to be based on a protocol filter if it detects BitTorrent-like packets. AFP, that's also a protocol. CIFS, that's the Samba protocol. Dropbox also has their own protocol. Some of these are websites, some of these are protocols. So common theme here is that we don't only have websites we can block like we would be able to in DNS, but we're also able to inspect the type of traffic, whether that's the port, the TLS header, the ALPN, which is the ALPN application level protocol negotiation, which is part of TLS. So if you're doing a secure transfer, even on port 443, it can still tell if it's not HTTPS. Like if you do, like, say, secure IMAP or secure POP3, on port 443, it's still going to tell the server it wants to do IMAP, and this can still detect that. If we go down here, like network management, we have all the big stuff that we would normally allow. It's like domain name resolution. You probably don't want to be blocking that one, but we have some other options too. LLMNR, everyone's favorite. MDNS, everyone's other favorite. If your users keep doing VPNs too, you don't want that to happen, we got you here. So we got all the major VPN sites, but then in addition to that, we have the IPsec protocol. But if you're using IPsec, you could block that one. If you're using Mulvad, you could block them. OpenVPN is, again, a protocol. We could block OpenVPN. Point-to-point tunneling protocol. Tor. Who else do we got? WireGuard. Zero tier. No need to block Tailscale. That'll get caught by the WireGuard filter. And lastly, web controls. So web controls are a bit different from application controls. Application controls is more focused on large categories of sites, specific networks, network protocols, VPNs, things like that. Web application is more based on content filtering. So these are going to be where some organization, and that's part of why you pay for Zenarmor, to get feeds of this kind of stuff, but somebody has gone to large numbers of domains on the internet and tried to put a name on what category they belong to. And so these are sites that may not be as major as the ones in the application side. We're not blocking all of Google, for example. We can come here, we can say no adult sites, no tobacco. They also have some templates here for moderate control and high control. Depending on what your environment you're in, you might just want to pick high control and be done with it. So moderate control is going to block adult, advertisement, hate and violence, drugs, okay. The really good stuff. And then high control is going to add on the more mediocre stuff. So this would be like blocked at work, blocked at school, pretty normal blocking stuff. But not sports. We got to have our sports. Can't block that one. And last up, the exclusions tab. If you have something getting blocked by the filter accidentally, you can exclude it here. I personally haven't had to use this, but I don't know, I'm not that aggressive on what I'm blocking. So now that we've taken a look at what we can configure in a policy, let's go through the steps to set up a new policy for a student network. So over here, I've got a Ubuntu VM. This is going to represent my student computer. We're going to try to set up a new student policy, add this device to that policy, and see what we can block. So coming over here to the Policies tab again, we're going to create a new policy for students. So we're going to go here and edit this policy. So because this is not the default policy, we actually have a configuration tab now. So there's a number of different items in the configuration tab we can configure. from the device type, the MAC address, the IP address, VLAN tags, things like that. All of these options are ANDed together. So if we said we want to be on VLAN 9 and an IP range and MAC address, all of those have to fit. The only exception to that is devices and MAC addresses are treated as an OR, because internally a device is a MAC address with a name. In my experience, most of the time you don't need to specify all of these things. So most of the time you're going to be picking a network, and then you're either going to use an IP range or you're going to use devices or MAC addresses, not all of them at once. So in my case, I'm going to say I'm using IJB1. So that's the only interface I'm actually protecting with Zenarmor. I could add a VLAN ID, but I don't need to. I can come down here and look at devices, IPs, or MAC addresses. If I were actually trying to protect student networks, I would probably have like separate subnets for them. I could just put those interfaces in here, be all done with it, wouldn't have to specify individual devices. But if I wanted, I could go in here and pick individual devices. So I could say, so my VM is called Applard VM, I can add that as a device. In theory, you can add device categories too, but they didn't work for me. I have no idea why. Adding smart glasses should add the VM that is part of a smart glasses category, but it didn't. You can see here, this is actually the MAC address of the VM. So I could come down here, put the MAC address in, or I could add an individual IP address, things like that. At the very bottom, we have users and groups. So Zenarmor supports integration with OPNsense's captive portal and also with Active Directory. I'm normally not a Windows person. I don't have Active Directory. I use a MacBook, and all of my servers run Linux. No Active Directory in this house. However, the OPNsense captive portal could be useful. And lastly, we have time schedules. We'll get to that one in a bit. So now that I'm at my VM, it actually adds the MAC address. And so even if this gets new IPv6 addresses later, it'll still catch it because they'll all share the same MAC address. Of course, your devices could change their MAC address. That's what student devices like to do. So what you probably actually want to do is make the default your most restrictive. So bin everyone under default, and then whoever you want to give less restriction to, put them in a less restricted higher tier and exclude them. If you try to go in an all-inclusive, you're going to be battling people changing their MAC addresses all the time. Kids know how to get around blocks, is what I'm saying. So then we're going to enable this so that it actually works, and then come on over here and block AI. Go ahead. Caught Google Bard. So to go Google Bard, we got an error. What if we try to go to, it keeps trying to redirect us to the secure site. That one's blocked. So next up, if we need to do any troubleshooting, they have a log viewer that makes this very nice and handy to see who's going where. So over here, we go to live sessions. So there's a lot of stuff going on, but we're going to filter. And this is one case where the device category does work. So I'm going to pick smart glasses, and there we go. So here, this device tried to go out to Google Bard, and it is a student policy, and it got blocked. So if you're having trouble with things getting allowed or blocked, you can come here, take a look, see what policy got dumped on, whether it was allowed or blocked, what went on there. So now let's take a look at some of the analytics we get with Zenarmor. So last on my tour of Zenarmor features, we have the analytics. If you've worked in IT for a while, you know that higher up people like to see pretty graphs, even if they're completely meaningless. That's why Unify is so successful with their Dream Machine family. Lots of pretty graphs, no function for them. Can Zenarmor do better? So here's what my main page looks like here. So it says I've detected some threats and blocked less of them. So I guess it's insinuating I should fix my rules to block more things. A lot of these are malformed DNS packets, and I'm not sure why it's flagging those, so I guess I have to look at that more closely. This guy is our top host here. It's probably my desktop. Top apps, media streaming. Actually, maybe this is a TV. Yeah, could be. Could be my laptop, I guess. I don't know. So we also have some basic status of how things are going. So I'm not using the cloud agent because I'm just using the local UI within OPNsense. We're running MongoDB. We're using a whack ton of memory. And our CPU is not the happiest with us, but that's okay. So next up, we can hop onto the Reports tab, which is where the actually useful information is. Should also note, the Reports tab is kind of slow if you use MongoDB. Presumably this would be better with Elasticsearch. There's a lot of data here. It takes a little while to load it. Just doing a quick look. So Amazon Instant Video is real popular today, the last 6 hours. And that's all by TV devices, which makes sense. So someone's streaming a crap ton on the Apple TV. And it's these two Apple TVs, which makes sense. Now I can also go up here to filter, and I can add a whole bunch of good stuff here. So let's say, for example, I want to see, I can pick a specific device out of this. So I pick you, that'd be my desktop. Let's see what my desktop has been up to. Secure web browsing, Discord, DuckDuckGo, Quick, Google, Bing, Mozilla, MSN. Who the hell uses MSN? But yeah, this is the detail of a specific host. Is obviously just the desktop because it's just one device. We're going to the firewall a lot, which... Why do we go to the firewall? Oh, because I've been recording this video on the firewall. Yeah, we've been doing a lot of data there. Next up, we have the Threats tab. Let's see what this is going to load for us. So it has detected a lot of DNS over HTTPS and some proxies. And we appear to be allowing DNS over HTTPS and blocking proxies. Mozilla Cloud, oh yes, that's Firefox's default of overriding your local DNS. And iCloud mask appears to be being blocked. DOH, yeah, this all looks a bit normal to me. All the way down here, top countries. That's the center of the United States. That is probably not the most geographically useful. How about we increase that a bit? That's still the center of we have the United States and we have the city of Chicago. How beautiful. Not the most useful. So similar to the Threats tab, the Blocks tab has everything that's been blocked. Proxies, park domains, the usual stuff. Hopefully this gives you a feel for what kind of data you can expect to find in Zenarmor if you're looking at it for analytics. Data is certainly there. Depending on what you're looking at, it might not go that far back historically. If you're using MongoDB, they only recommend storing 2 days of data. So if you're trying to look at a problem, you're probably going to be looking at it in the short term and not looking at long-term trends. Which probably makes sense because if you're using some sort of long-term analytics solution, you'll probably be using something like InfluxDB or Prometheus to store your data. There's also no way to export your data beyond MongoDB or Elasticsearch. You can have it forward your data to a remote Elasticsearch server, separate from the Elasticsearch server you're using locally, but there's no export to something like InfluxDB or an API like that to a time series database. So you guys have come along on my tour of Zenarmor. I've been using it for about 2 months now as of the end of this video. I started it about a month in. I started making the video. And I've learned a lot about how Zenarmor works, what it's good at, what it's not good at, if it's useful for me or not. So to answer your questions, first of all, am I going to be keeping Zenarmor? No. That doesn't mean it's not a good product, but I don't think it's useful for my home use case. I am not particularly aggressive about filtering content of my users. Most of my users are adults that can manage themselves. I'm not trying to block people from getting to their favorite websites on the internet. I'm not running a business. I mean, I do YouTube, but I'm not running a business with employees. I'm not running a school. I don't have users who I need to restrict their access to anything. And that's why I don't feel like Zenarmor is going to be helpful for my personal use case. That said, if you're an administrator running a larger network like that, Zenarmor may be a great solution for you. So I don't directly work in school IT, but I do work with a school. I'm a robotics coach, and so I'm somewhat familiar with the challenges they face in trying to restrict student access. And it's not even always that they necessarily want to, but they're required to for certain contractual or legal reasons. And so if you're in that sort of scenario as an IT admin, you have to implement something. Zenarmor could certainly be a choice for you to implement. Now another topic that comes up a lot in next-gen firewalls is TLS inspection. That's something I am strongly opposed to. So in general, if you're doing TLS inspection, you're going to stop all TLS transactions at the firewall, the next-gen firewall. You're going to inspect the full HTTP traffic. Then you're going to re-sign them with a locally signed certificate for your clients. All your clients are going to be forced to accept your locally signed certificate that's going to be generated on the fly for each site. And this breaks a lot of things. So a lot of modern apps rely on the security of TLS. And when you break that end-to-end encryption, your client knows something is up. And you can tell Windows and you can tell macOS to trust that your firewall is actually good, but a lot of apps aren't going to believe it. So Git, for example, has its own trust store. It doesn't believe Windows is trust. A lot of apps will do certificate pinning. They'll check to make sure that the certificate is actually issued by them and not by someone else. So a whole bunch of apps will break because you've broken this chain of trust between your users and their website, and between your software running on your users' computers and their website. So my opinion is that if you're worried about the sort of threats that TLS inspection would deal with, you should just block those websites outright. But again, that's my thought. Also, on a related note, I did eventually find out that those 250 some devices that were all previous temporary IP addresses, those don't count towards your license because they're not active. They're just there, clogging up the display. So there's that. I don't think there's anything else to say about Zenarmor, but if you have any questions, I have it running still, and you feel free to ask them in the comments. I have a Discord server linked down below. If you want to chat with me about networking topics, I'm always there, always responding. Got a great community. This video is not directly sponsored. Obviously, they sent me the license, but that is it. So I'm making this OPNsense series on my own. If you'd like to support me in the work I do, I have a link to my Ko-fi down in the description below as well. And as always, I'll see you guys on the next adventure.